This conference will now be recorded.
All right, keep going, sorry.
I think the agreement was in the chiplet die-to-die use case, you needed to be absolutely sure that there were no errors on it. So the main service a chiplet link layer provides is the error robustness, and you have to use extra bits to carry the CRC. So that's the price you pay. And then what what they're saying is, if they're saying that the use case doesn't require that error robustness, and yes, I guess you don't need, you're doing away with the main service. Well, yeah, then the main service the link layer is providing is not really relevant to that use case. But I would challenge. Yeah, I mean, my understanding is error robustness is a requirement, and
Okay.
And the point is you provide that service at the link layer rather than at any other level in the stack.
So then the trick question becomes, how do we use the extra 2 bumps in the bow interface so that we don't waste any of the data bandwidth?
Well, then that is how you map or pack
Right.
the interface from the lower level client interface of the link layer to the service interface, the bow, and if what you're saying is that extra bit is available for data, well, you could repurpose that bit for data transport, I suppose, and then that would solve that problem.
Yeah. So will we do the mapping, or do we expect the bow group to do the mapping? I think that's here.
It doesn't really matter. It could be done within this group.
Okay, so this is where
I think wasn't the I mean, the things I suppose you haven't really been doing the detailed grant work, but I mean, I think the objective was to define a generic link layer that could be used with a variety of PHYs, and then kind of do a worked example for bow, and that would mean an extra maybe sub layer, lower link layer, if you like, to map between the generic layer. Well, define how you get from the generic link layer to the bow service interface.
Okay. Who do we normally get? Oh yeah, okay. Let's see. Well, anyway, so this is where we ended up last week. I think it was you and David. Greg, you don't happen to know if David's going to be able to join us? And who else was here last week? Oh, that's right. Gary's on vacation. Okay, then it's just just a small group today. So this is where we ended up last week. These were the 2 questions from the bow group. Do you always need ECC?
What does it mean by that, Bobby?
Sorry?
ECC as in CRC?
Yeah, any form of error detection. Correction.
Any form, okay, any form, okay.
Is it worth burning the overhead? Is the question. And I think I'm hearing Arthur say yes, because that's the primary service. Link layer service. and 2, because not clear that any D2D interface can actually meet the reliability requirements. Those are the 2 answers I'm hearing, right?
Yes, the assumption is you need error robustness in the chiplet use case, and you provide that service within the link layer.
Yeah, I mean, I'm hearing that even for Open HBI, they still want the retry capability. Yeah.
So then the mapping the extra 2 bits to the FEC in Bo, there's no barrier to doing so, right?
Yeah, in my case, I mean, the FEC and the data is pushed down a 512-bit data path. I don't have this idea of 2 extra bits.
Well, I thought the FLIT had 2 extra bytes.
Yeah, but it's shift and merge. It's packed into the. I mean, the lanes are still 512-bit, or 2 to the n. It's not. I don't have like 16 bits and then these 2 extra bits for miscellaneous. It's not like the boat. It's just a lane has either 8 bits, 16, 32, or 64 bits per lane, and then I can have n number of lanes. So it's all the resolution. It's all the width of the lane is a multiple of the flit width, or the.
So do you then just offer less bandwidth to the transaction layer? Is that how it works?
I just consume, like, my overall bandwidth is n lanes by, say, 64 bits, right?
Okay.
And within that bandwidth, I have the data, the payload plus the FEC, and I just effectively straddle the flit boundary to basically push in the payload plus the FEC at the end, and it just wraps around after so many flits. I basically extend the flit to, say, 544 bits, for example, right? But my data width is still 512. The number of lanes I'm consuming is consuming 512 bits, and I do what's called a shift and merge. I basically just wrap around at the boundary and push the data down. I don't have these extra bits, sideband bits. There's no extra sideband bits to find. You won't see that for an XSR or USRFI.
Right. So I guess the question is, so in your case, if you turn off ECC, basically you can just use the entire 512-bit flit for data, basically. Okay.
Yeah.
Okay. So that brings us to, so there's one other thing I wanted to ask you guys about. The bare wire case where we treat the die-to-die PHY as a wire, kind of a wire adapter case. I feel like we haven't considered that enough. Just, there's no protocol, no nothing. It's just bits streaming as a wire. Will the FLIT work for that as a wire adapter as well? This is just my question, not the Bo question.
I still don't understand the term wire, exactly what you mean by
Imagine
that.
I have like a 512-bit bus in one die and a same size bus in the other die. And I want my 64-bit Bo interface or 16-bit Bo interface just to sort of literally map the 512 bits on one side to the 512 bits on the other. One 512-bit word at a time.
So is that just accumulation, and you just build up your 512 bits from your 16 bits and send it across?
Yeah, that's it.
Do the opposite.
Yeah.
I mean, that's effectively what it. It's effectively what I would do anyway. If my interfaces were less than, my application interfaces were less than 512 bits, I'd have to build up the flit. And
So I mean, in a communication protocol, you you kind of define service in interfaces, and what you're talking about there, Bap, is a completely raw interface. So I mean, it's just, if I understand you correctly, it's just 512 bits, and you clock it in, and then you see it the other side. If you define a link layer, you normally have a bit more there. You'd have a valid signal and perhaps a ready signal and things like
You'd have some
that.
framing structure, like if
Exactly.
yes, I mean that's what we.
And
Yeah, I mean that's what the.
so I mean, if the if the if the homework has been define a link layer, that kind of means you define a service and you define an interface to that layer, and that's kind of what we've done. And it's fine to say, oh yeah, I'm not interested, and then you get a raw interface, but it's yeah.
Okay.
Sorry.
Yeah, not sure what it's. Yeah, I mean, I have I suppose the physical layer effectively would do basically, so the file would look like a raw, or as you say, basically a wire interface, just a raw 512 bits in, 512 bits out the far side. Sitting behind it, then I have a physical layer which is going to provide some mechanism to frame blocks of data. So add a valid or whatever, or just do it in band with markers effectively. And then above that then is the link layer, and the link layer fits into the framing structure below, and it's usually all nicely aligned in terms of the flit width is aligned to the framing structure below, which is aligned to the data with the lanes of the PHY.
And in terms of terminology, I'd agree with Damien. I'd call that a raw PHY interface rather than a wire interface. That's
Well, I call it my pipe I get exposed to. Basically, just
right. So you're saying again, it's more. You're saying this link layer shouldn't be used. We can't realistically expect it to be used as a raw PHY interface, basically.
well, then it wouldn't be a link. Yes, sorry, go on.
I guess I'm asking: is there sort of any there's a nice mathematical word for it. Anyway, there's some configuration of the link layer where you can run it as a streaming interface. Essentially, just sort of say, okay, I get raw bytes in, raw bytes out. There's nothing I do to it.
I think in Gary's case, isn't he? He uses the extra sidebands, and he effectively takes the output of his link layer effectively and maps it to the bow, and he uses these extra 2 bits to give himself a valid and give himself this additional FEC bit, and he doesn't necessarily have. That's his framing structure. Basically, is the sideband valid per cycle, or he doesn't have kind of an in-band framing structure. He just has. He's using additional bits. I think 18 bits. So his resolution is 16 bits, and he defines 18-bit chunks effectively.
Well, I tell you, the use case I came across yesterday, right? That is like we're assuming that there's a transaction protocol. Basically, we're saying we're replacing both the PCI PHY and the PCI link layer with a die-to-die PHY and a die-to-die link layer, right? This use case is like, imagine somebody has a PCI PHY, right? But you don't actually have wires on a board. You have basically that talks to some kind of a imagine that talks to some other kind of medium. You're just replacing the wires on the board with another medium, and you're trying to map the 16 PCI lanes onto 64 wires, low speed wires, or say 64 wires where each wire, it's kind of a reverse bow mapping. So as far as the PCI PHY is concerned, it's actually talking on a PCB trace, but in reality, the PCB trace has been replaced by a multi-lane cable.
Okay, so it's just a pipe interface.
It's not. It's under the PHY.
Yeah.
It's under the PHY. The PCI PHY stays untouched. You're literally
Okay.
taking the outputs of the PHY and remapping them. The entire PCI controller design, the PHY, everything is untouched.
Okay.
Like it's going to look like this. Let me see if I can. Give me 1 second.
You're just connecting the TX and RX together, basically. So it would be a cable.
No, I'm doing a hash job of describing it. Give me 1 second.
Yeah.
I think I understand what the author is saying, and maybe that's the right answer. That you're asking for a link layer, and now you're saying you don't want a link layer is the right answer. I'm not able to get a. Okay, I'll just do it on this diagram. It kind of looks like. So let me see if I can explain it correctly, and then you can. We don't have much of a quorum tree.
You're not sharing screen.
I'm doing it right now.
Oh, thank you.
Sorry. So imagine you like this is what we're thinking of, right? Today we're thinking of like you got this PCI. Oops. The heck? Can you see my screen?
Yeah.
Except that it froze. Okay. Imagine it's like this. So this is, and I think the more I draw it, the more I realize that maybe this we can't do this. So like this is a PCIe PHY, and then I'm using PCI as an example because it's and then you got the PCIe link layer, and you got the PCIe transaction layer, right? So far so good. And
it was
then, okay.
yeah, there's a physical layer in there, but
this one, right? PCIe PHY.
Yeah, between the PCIe PHY and the PCIe link layer, there's a PCIe control, like a PHY-MAC logical layer, PHY logical.
Ah, okay.
Yeah, but
right.
just to,
okay.
If you want to draw the layers, yeah.
PHY logical, and then on top of this, you got an AXI bus or something and a chip
transaction layer, yeah, some description or something, yeah.
AXI SOC talks to this PCI transaction, right?
Yeah.
Okay, so then the model we're doing is we're taking this and we're taking this and then we're saying we're going to replace the PCIe PHY with a D2D PHY. And we're going to replace this with a D2D link layer. Right?
Yeah, yeah.
Okay, so then there is an interesting alternative model.
So yeah, so the die-to-die link layer is the PCIe LL and PCI logical. That's what we're saying, right?
Yeah, but okay, so then the other alternative model is, so you take this, leave all this untouched, put it underneath this, and you have some kind of a custom cable.
Why would you do that? Why would you do that, Bappy?
So this custom cable offers you, so let's call this a custom. So now you can leave it. Well, there are two reasons from what I can figure out. One, you can leave your entire chip untouched for almost all practical purposes. Most of your logic gets untouched, right? The only thing you're going to add is like a D to D phi. And this cable gives you properties that a board trace doesn't. It's higher bandwidth, it goes for a lower latency, and it can get you from point A to point B faster.
But it's not low latency because you've got extra layers in there.
You got extra layers in there. So this is one device.
But okay, with the PCIe Phi connecting to a die-to-die link, but that's an analog. What connection is that? So that's some sort of wire. Okay, it's some sort of wire adapter. Okay, it's just you connect the lanes together, right?
Yeah, exactly.
Okay, and then so we.
So is this all on one chip?
This is the chip boundary now. This thing.
Yeah. You certainly wouldn't have the PCIe Phi in there.
Sorry.
Yeah, why would you have two phis?
Because you're just taking your PCI controller, and you don't want to change anything. You're just taking your PCI controller as is. It's outputting. It's throwing out a bunch of wires, right? It's throwing out 16 lanes worth of driving 16 lanes worth of something.
Right.
Yeah, that Phi is a high-pad SerDes, so you don't want that.
No, let's just say you want it for argument's sake. You're not trying to optimize anything. You're just trying to take a design that exists and use it as a bare die.
And the other guy is a die-to-die Phi, so
you essentially need a wire adapter. If this has 64 wires, you take these 16 wires and spray the bits across these 64 wires.
Okay.
Bapi, I have a couple of questions. When you have a Phi to Phi, I'm sorry, PCA Phi to talking to the D to D Phi, the
Right.
protocol itself is different, is it right?
No, these are just bits. This is like the you're as far as this die-to-die Phi is concerned, it doesn't know whether it's carrying PCIe or AXI or anything. It's just seeing a bunch of streaming bits. It doesn't care.
And because PCA requires quite a bit of hand holding in terms of protocol, D2Phi is just a it doesn't care what is there, it is sending and receiving. That's pretty much it. And the second one is electrical characteristics point of view, how the PCA Phi is going to interface with D2D Phi.
How the PCIe is right. You're coming back to the AC coupling, DC coupling thing, right?
Not only that, even if you ignore that, let's say even if you have a DC coupling, because D2D Phi is not a single bit interface, it's 16-bit interface, whereas PCA, it is serial and maybe 16 lanes require them to be mapped to 16 lanes of D2D Phi. But whereas D2D Phi interface expect the data to be 16 times 16. So those kind of logistic issues, even if we don't see electrical issues.
Yeah, okay. So it's an unreasonable ask to have this wire adapter. Okay, that's a...
Yeah, it won't work. I mean, so I mean there are all sorts of problems with this, but the main one is you've got a PCI Express Phi in there, and just think of that as a 32 gigabit SerDes streaming out serial. All right, you've gone there. Yeah,
it won't work.
So,
okay.
So that wire adapter would have to deserialize the data coming in, which is quite a big job, really. And then on top of that, a PCI Express Phi is a high-powered piece of kit in all sense of the word. It takes up area, it takes up power. It just makes no sense that. I mean, if you got rid of that, it might make a bit more sense. But got rid of that PCI Express PHY layer. But even so, the problem. The problem with a stack like that is its latency.
And this is not an AXI terminal, but this is just raw bus. Then this would make more sense. Then you could just, you don't even terminate AXI here, you just treat it as a raw bus and have a D2D wire adapter. Then this would make sense. All of this in the middle disappears.
Yeah. If you're happy with a raw, yeah. I mean, what you're basically doing is you're connecting direct to the raw PHY interface there.
Okay, now for this, can the link layer we're defining be adapted to connect one raw bus to another raw bus like this? I'm asking, not commenting.
Well, it wouldn't. Well, if it's raw, I mean, that's not what a link layer does. I mean, link layer provides the service and provides a different service interface than the raw PHY interface. So.
Okay. Sorry, I just saw this use case.
So the reason you want a raw interface is you think it's more efficient in terms of bit usage. Is that where this coming from?
No. This technology exists, and I'm just checking to see. And so there's a bunch of people who say, look, I just want to treat my die-to-die PHY as a wire. I really don't want to do any new protocols. I don't want to. I don't want to have a new die port adapter and everything else.
Well, in that case, so then they're not interested. They don't want the link layer, which is fine, you know.
They just want the PHY.
Yeah.
Right. Or will the streaming interface model work? Will basically, can the link layer just basically serve as like, okay, I'm going to bucket this many bits together and deposit them on the other side? I'm really.
I think we have, Arthur, for our version of a link layer, we have the services of the link layer, and then we have this idea of LPIF on the far side, where we map the application interface to lanes, right?
Okay, so this is fundamentally compatible.
Yeah, so if you decide that you just want some sort of wire interface and you don't want to service the link layer, then the link layer comes out, and all you're left with then is your application interface coming in, and then you're mapping to the LPIF, whatever. You just have a mapping from application to lanes, so flits to lanes. That's it.
So actually, I suppose like we could throw the question back to the Bow group. I mean, what service do they want? I mean,
No, this is not from the Bow group. This is sorry. So just okay. So 1 and 2 are from the Bow. 1 was from the Bow group. 2 is from me. This one is from me because I came across. I came across this interesting technology yesterday where you can basically just have a highly parallel wire cabling structure between two SoCs. And their question was, hey, can you model it as just a wire, and can you just put a wire adapter? And then I said, oh, because basically if you need just a wire adapter, I have like 128 wires on one side, but you know I've got 512 wires on the inside, 64 wires on the outside. I literally need like some kind of a muxing thing, and that's it, a serializer, deserializer. And does that, and my My question was, does that have anything to do with our link layer? And you guys are saying, no, it has absolutely nothing to do with the link layer.
Well,
And I'm not complaining.
so
I'm not
so there is a service there. So basically, if you're going from a wide interface, if you're multiplexing a wide interface down to a narrow interface, you can provide a sort of unscrambling, what's the word,
Shuffle,
service.
I call it.
Shuffle, yeah.
Shuffle.
So what you could do is you could define a training pattern. I mean, the nice thing about die-to-die chiplet environments, it's not plug and play. You know, it's a fixed engineered environment. So one service you could do at Power Up is you could set a training pattern which allows you to unscramble those lanes. So if you want, I'm sorry, I can't remember the details of Bo, but supposing the requirement was to go for a raw 512-bit interface to say a 16-bit interface, you could, I suppose, define a bring up mechanism to unscramble all that. But
or like does our link layer involve these queues? Like it does, doesn't it? Like you're often that is it or not?
Well, the I mean, the original concept, and this can be changed, was you'd have a generic component that doesn't do DSkew, and then you'd have a PHY specific component which would do the packing and the DSkew and bring up training if necessary.
Yeah. The reason, actually,
okay.
that's what I have. Yeah, it's still fine. Yeah, sorry. So yeah. So
all right,
link training and DSkew is the reason I mentioned link training and DSkew is all the one thing to me, because that's when I do the DSkew is when I train the link. That's what I'm getting. So like it's the transmit sequences that actually are used to implement the DSkew in a drift buffer.
So what sequences are those, Damien? Do they ones
you like if I'm just looking at the partitioning, so if I'm bringing up a link, what I would call the PHY logical or the physical layer in the controller, let's say, is the guy that's responsible for the link training. And if I'm training the link and it's a multi-lane link, that training process will also do the DSkew between the lanes. And at the end of it, when the link is up and training is completed, I'll be sending, a synchronized flits worth of data up to a link layer, or receiving data from a link layer, sending it on. But the link training and the DSkew is all wrapped in. It's all one. It's all one process, basically. It's not something that's additional. It happens after training. It's while training is happening. While training is occurring, I'm also doing the DSkew. And at the end of it, I'm finished the DSkew. I'm finished the block alignment. I basically framed. My framing is part of the jigsaw is complete, and I can now talk to now I can talk to the link layer above me, basically. So I was trying to get this boundary in my head for this ODSA link layer where we have LPIF, a generic LPIF interface, talking to some PHY, and we have this idea of an adapter in the middle. If the interfaces weren't compatible, it's fine. But the actual what's it called, shuffle, reshuffle, or the retraining was back. Now resides in the ODSA link layer, if that's my understanding is correct.
Okay, so that's a good. So I've sort of been dancing around. We don't have much of a quorum today, but when we left last week, these were the things we were thinking of as next steps. This is that, do we want to discuss any of these, or do we want to wait to build up more for quorum? This is what we had, that there were 3 options on coding: none, weak detection, and strong detection.
To me, actually, I'm just looking at the link there. To me, I'm pretty clear on the application interface, or we can define that. It's fine. Pretty clear on what we need in terms of protecting the, a flit, or protecting the data, CRC, FEC, whatever. It's
Oh,
where I'm a bit fuzzy is the layer is the interface from the link layer
oh wait, Damien,
to
you
physical. Yeah.
you were going to do an overview of the flit, right? Can I? Are you going to be able to join us next week?
For half an hour. But
Do you want to
yeah,
move the meeting up if or by to 8:30 or something, or um, there's a lot of interest in the overview of the flit. That much I know. So if you can, if you think you can be there for sure, I will send out a notice saying you're going to do a flit overview.
okay. Yeah, yeah, but see, half eight, yeah, I can. I have a yeah half hour info. Yeah,
Do you want to start at 8:30 Pacific next week,
well, yeah, it suits me. It's
Arthur?
Suits me. Yeah, it's really good for me. Yeah.
Okay. Why don't, or I don't actually mind moving it up by a whole hour to 8 Pacific. Let me find out if anybody else, if it works for anybody else. But then if you can do with the flit, so then we can, should we start here? I mean, this whole, do these things sound like good problems to solve? I know you also had on top of that, you just said the file link layer interface is not clear.
well, okay. I'm fine with LPIF. I'm trying to work out what's behind it and what's in front of it in terms of
I mean,
yeah.
the bring up and training requirements are FI dependent. So I mean,
Yeah,
if you've got a good quorum in the bow group, you could define that there.
yeah,
So you understand the requirement mapping. I mean, so auditors, you have multiple bow instances, and you want a mechanism to deskew them, and you want a mechanism to do block alignment, for want of a better word.
yeah. See, I have So if I look at, I have these queue cross lanes with block alignment within a lane, right? It's like my physical layer is lanes on one side, and then it's a flit
Wait,
on
wait,
the
wait.
other.
Wait, so just one second. Well,
Yeah.
so I want to show you something. I thought, let me pull up that. But I do want to get your agreement since we don't have much of a quorum today. If next week we let me pull that up. The heck? Oh, okay. So if I wanted to get your agreement on two things. One, next week, Damien will do a overview of the flit, and after that overview, do we start with this? Do we start with whether what the options are on coding? I'm asking, not recommending.
Yeah. Actually, do you know what I'd
By
like to?
by coding, you mean the coding, whatever code. By coding, you mean what you have to do, what you add for error correction. Is that what you mean by coding?
Yeah, so my understanding is that we want to support three options. No error correct. Okay, so let me say. My understanding from last week was that we wanted none or weak detection support for a parallel 5 and strong detection support, strong correction support for serial 5. That those are the three use cases we wanted to consider.
Yeah. I mean, I think on last week's call there were, I can't remember who's on it, but I think there's somebody objecting to retry, and I can't remember why. But I mean,
So
when we
yeah.
but I mean, when we've, I mean, my recollection of the consensus, other than last week, was none wasn't really an option. Well, I suppose it was optional, but the point, the assumption was you did need you did need error robustness, and the three options were CXL type retry, or which works with things like Bow, or if you're using a high-speed SerDes, you'd have two levels of FEC depending on whether it's a PAM4 SerDes or an NRZ SerDes. So those were the three error correction mechanisms I thought we had consensus on. And what you could say is they're all optional. You could find them all and make them all optional. So if somebody really wanted none, they would just turn them off. However, I think some people, did somebody say they'd rather strike? Actually, I think somebody said they wanted to get rid of the retry because it would add complexity and wasn't necessary or something. But
or was it bandwidth problem or something?
No, wait, but
no, I think
before sorry, I have a hard stop at around 9:50, 9:52. So I want to figure out whether this is the sequence in which we want to do things. Is this
I
sound like a
think
good?
having a tutorial on flits and CXL is a really good idea. I think that's excellent. Yeah.
Okay, so then 6:24:21. Can we go after this? The coding and error detection correction options.
Yeah. Can we eventually get to block diagram?
Okay, so we
The
do
whole,
that first. Should
of the
we?
whole thing. Just
Okay.
at some stage you're going to have to just put down on paper what the functionalities are of all the
Wait, I
different
thought we
errors.
did that in this paper. That's the thing back and forth we did on this paper.
Yeah, I'm thinking more of a spec. Like we have to put. I assume we have to write down something on what
Right,
an
but
actual.
my understanding is that we're going to go. Okay, so block diagram. That this is the first part of the block diagram we're starting on. But the error detection and coding is the first part of the block diagram we're starting on. Is my understanding. Is that wrong? I'm asking again, not recommending. I guess my question is, which part of the block diagram do we start on first?
So Damien, next week will you explain to everybody about the CXL retry mechanisms so people understand that in a bit more depth? Is that what you?
I can, yeah. I just
I think that would help the wider group's understanding of what we're trying to do.
Okay.
Okay, because okay.
Okay, so then the week after we agree on which part of the block diagram to start on, correct? That's somewhere I want to get some consensus on what do we do next. That's really what I'm hunting for.
Yeah.
So I've been assuming that the error detection is the part that we want to start on. You're saying that not so fast? I'm asking again, not.
Yeah,
No,
I'm pretty
I
clear on
agree.
that. I'm agree with Arthur. I'm pretty, more or less what he's stated on. I mean, I'm pretty clear on the options.
Yeah,
Right,
and
so,
I mean the main service is the error correction, so that is a good place to start. And once that is defined, then lots of things fall into place. And I think and I think if you take the CXL template, that takes you a lot of the way there, because that defines a flit format, and it defines a CRC mechanism, and it defines an error correction mechanism through retry. So that's very good reference. Yeah.
Yeah,
okay.
we've just the other thing is we've the actual physical interface is CXS. So it's actual. So it's the CXS interface carrying a flit which encapsulates the CXL protocol. So that's the actual physical connection at the top.
Sorry,
If you know
above.
what I mean.
So is that's the interface to the above the link
fit,
layer?
yeah, the physical interface in the link. This is what my link. The link layer physical interface is a CXS interface, and a CXS flit is a CXL flit effectively. I'll try and describe it better, but the actual connection is the actual connection is defined as a CXS interface. So it's a flit-based interface, but it's just a CXS interface.
Okay.
And the link layer is effectively split in two. The lower guy, responsible for the robustness, right, and the transfer of the flit, with the upper guy responsible for flow control and packing, packing.
Okay, and CXS is again is an open standard.
Open standard, and there's and
so that might work really well as well in an ODSA standard. So if CXS be yeah. I mean whatever we do, I mean the industry kind of has its own momentum and the thing is that lots of things are being thrown up in the air right now, and they're sort of coming down in various things, and yeah, okay, I've heard CXS versions be mentioned a lot as well. So I mean, if Damien likes that and it works, and it's a predefined standard, it's open, it's might be nice to get that in there too. So yeah,
I can tell you, I can see what we've done. Yeah, it's restricted. Like it's not the full. It doesn't allow for all the options that CXS give you in terms of.
Hey guys, so I'm going to drop off in 2 minutes. So
yeah, I'll include it next week as well. So
this sequence is good. Arthur, Damien, Satya. I know you guys, Satya is new, so it's unfair to ask him, but I want to settle on a sequence going forward, and then that this is what we're going to do for the next few weeks. And is this
okay? Let's go top down. So I'll do application interface, flits, blah blah blah, push down into the actual error correcting mechanisms, then push down into the actual interface to the PHY or to the PHY adapter or whatever we call it.
So you're doing the CXL flit overview and including CXL retry. 624, we say this is a block diagram. 7.1, we start on the coding mechanisms. And 7.8 or on 7.8, we try to figure out on the retry. Roughly, that's is that a good sequence?
Yeah, I'll touch on the retry. Yeah, well, what's the retry at the bottom? The 20.
Just specifying it. Yeah, I think we're going to specify each portion in order, right? To specify the block diagram and sequence.
Yeah. Okay.
Is Ethernet part of the layer 2 or is not?
We're not. We haven't defined an Ethernet adapter anywhere as a die-die protocol. We've seen PCIe, but with no real there could be a demand for Ethernet. It's a fair question, but it'll be part of the.
I think Ethernet already has its own link layer, so I'm not sure. I mean, if you're sending Ethernet over it, I think you just go with raw Ethernet and you use what's already defined there.
Yeah.
I don't see any need to transport that over a different link layer or protocol. Ethernet already defines a full protocol stack, which is with end-to-end error correction. So Ethernet already gives you the end-to-end error correction. So that's my feeling. Well, yeah. Sorry, why do you ask? Actually, sorry. Where's that question coming from?
It's coming from me. I wonder if Ethernet, which is used pervasively everywhere, is part of the layer 2 analysis we are doing.
Hey guys, I really have to drop off in a minute. So my question is this agenda good? Then yeah, I can hop over and you guys can continue.
Yeah, no, it's good. It's good. Yeah, I got to go as well, actually. So, but
yeah, me too. Yeah.
Yeah, it's fine with me.
Okay, you like the agenda, Arthur? You like the agenda?
Yeah. I mean, yeah, it's great as a straw man. We could tweak it.
Change it next week.
Yeah. But I mean, it's something to work towards. So I agree. I mean, we might want to I mean, it's good to get it all down. Though we might reorder things a bit depending on how it goes.
Okay. So let's start on these 3 topics for now. Okay, Hisham, I'm sorry, I got to hop off. Thanks, guys. All right, if nobody else is staying on, I'll end the bridge too.
Yeah. Okay. Talk to you next week. Bye.
Okay. Bye.